Welcome to the 405th episode of CppCast, the first podcast for C++ developers by C++ developers. I'm your host, Jason Turner. I am the sole host at the moment. There is some talks about having a co-host in future episodes so that our listeners know. I am planning still for once a month cadence, just so you know. This is every fourth week will be a CppCast episode, and these are going to be crossovers with C++ Weekly on my YouTube channel. This week, I am joined by Daniel Nikpayuk. Daniel is an Inuvik. You know what? I already butchered. I'm sorry, Daniel. We will continue here. Go ahead, if you don't mind, just introducing who you are and where you're from, and so that go ahead, go for it.
The name was good. Inuvialuk. It's just a variation of Inuk or Inuit.
Okay.
Yeah, just more specific, like regional to my people in my area.
Okay.
Yeah, the umbrella term is Inuit, but
Inuit. Okay.
Yeah.
All right. Thank you for that. Daniel has a bachelor's degree in mathematics. His personal technology goal is to build a programming language to assist in Indigenous multimedia and storytelling. Thank you for joining this week on CppCast, Daniel. And sorry for the rough introduction, but we like to keep it real here. We're going to discuss a few news items. Well, you know, when Rob and I had CppCast, we tried to have the news very up to the minute, but since I'm doing this once a month cadence, these are just news things that you may have missed. So feel free to jump in. I'll mention some things if you had the chance to look at these or not. We have the Cache Explorer. This is supposed to be kind of like Compiler Explorer, I believe, but with the ability to kind of look at what your, so the idea is that you can see what caches your C++ project is using. Did you look at any of this? Did you look at this by any chance? Do you have any thoughts or anything?
I took a quick look. I didn't make use of it or anything, but I'll say I like the idea because, like, just how Compiler Explorer really helps you to like learn assembly and get better at it. Like I need something like this to see, you know, like cache hits and misses and get used, like build a stronger intuition for that. So I find it interesting.
That's a great way to put that. That's like, how much it affects the way we program when we have an intuition for how things should go together or how, you know, what impact this will have on whatever thing. I have here a link to Tscript, which is an embedded C++ scripting library. For people who have been following any of my stuff for a while, you would know that embedded scripting in C++ is something I've had an interest in for a very long time. And Daniel, I believe this is kind of also pretty close to your interest, although, well, we're definitely going to have to talk about that more throughout the podcast. But
Be happy to talk more about that later. I took a quick look, and just the embedded and scripting aspect of it I found interesting, and I had to go online and look at the differences and like how these things are done, because like I want to see how it's different from the way I'm doing it. So
right.
Yeah.
I'll just take this as my moment to rant to that please never, ever embed Python or Ruby in your C++ project. They were not designed for this. They have global state and they do not interact well with C++. I will get comments for that. I've seen the worst of the worst when it comes to these things. Okay, the next two things we have on here are just like, I kind of grouped them together. People playing with C++26 reflection, basically, is what we've got going. A Dear MGUI library that allows you to just directly expose a struct to your GUI so that you can edit the fields in the struct. That's neat. This is the kind of thing we've been waiting for, reflection. I'm very excited.
I don't know the IMGUI, like I'm not as familiar with it. Like I don't use that, so I don't have much to say, but definitely interested in reflection.
Yeah. And the next item up here is also a reflection library for exposing your C++ types to serial. Cereal, that's the name of it. Cereal as in like the food that you eat is a serialization library. This is called auto serial, which exposes your C++ types to the serialization library. I need to type these words out on the screen in editing so people can actually see what I'm trying to say.
Like my own project, which I'll get into, does its own version of serialization. So I was also looking at this a little bit. Want to compare and see the differences, but it seems very interesting.
Yeah, that's okay. We we're just, I feel like we keep like throwing hints to our audience about the kind of stuff you've been working on. But I feel like I have to start with the generic question of what got you interested in C++. And if I understand correctly from our talking before this, it was a bit of a journey that got you to C++, right?
Yes. No, I was thinking it over, and I probably it's a story. I probably have to break it into, I think. So yeah, I wrote notes because it's a big enough story.
Go for it.
Uh, okay. So I'd say a three-part story. First there's uh, first there's honors math and LaTeX. So with that, basically, when I went to university, this is early 2000s, like math was my major. At the University of Alberta, they have a honors math program. And generally, you can only take those honors courses if you're in the program, but they do give special exception to people from time to time. And so they gave me special exception to take those courses. And being there, I was exposed to a lot more than I would with a normal math degree, and also exposed to like different people and all the things they were doing. So for one, like I wanted to write my own LaTeX article, but then I had to learn LaTeX to begin with, which was a lot. That's probably one of my first programming languages. But at one point, like you want to include graphics or other things, and I was just looking at the history of LaTeX as like in terms of the software, and it goes back to tech with Donald Knuth. But, like if you look at the graphics packages, they're all like built on top, which I thought was odd. Like historically, it makes sense because when tech and LaTeX were built, computer hardware like wasn't good enough to support, it like didn't have a whole lot of RAM and everything else,
Right.
and so like it made sense to add graphics after the fact. But like if you start with like better hardware, then like it makes sense to start with graphics because ultimately like like typesetting, that sort of thing, like it's all visual, like glyphs and whatnot. And so you start with graphics first, then you can build on top of those.
Okay.
And so yeah, so in the early days that was definitely one of my biggest interests. Like I wanted to create my own. In my head I had the idea, but like I guess the idea was kind of brewing in my head, that I wanted to create my own programming language that way, or like a alternative to LaTeX where you started with graphics and built everything that way.
Okay.
Yeah. This also applies because I in university I took a design class, and so because I knew LaTeX, I just made use of it, and I wrote some like Inuktitut characters, or like their Slavic characters, and like Unicode support in LaTeX is like so.
Okay.
Yeah, so it's like I wanted to. Overall, I like the technology, but it's like it had its limits, and yeah, so it kind of inspired me to want to do my own version, like better version of it. Okay, so I think that would be the first story on my journey. The second one is so I took 2 years in university, but then I took a break, about a 5-year break, and uh, I was young, working at the time. I ended up working in Banff. It's a resort town in the Rockies in Alberta.
Like directly north of me, pretty much.
Yeah.
It's north as far as the highway goes. I guess you follow the highway up, you'll get there. Anyhow, go ahead.
Yeah. So I was working there, and actually, I was working a lot. I remember. I mean, these details aren't entirely relevant, but I was working as a manager at the McDonald's during the late night, and then in the day, I was working at a hotel. I was just front desk. I was definitely working like way too much, but at the same time, when you're working at front desk, you're just sitting, and so you can take a break from the hard work you do at the McDonald's at night. But yeah, so I was young, enjoying myself, but I also knew that I wanted to go back to school eventually, and I also knew I wanted to like build that programming language or software or like improvement on LaTeX. And so when I was originally in university, I took one computing science course, and we didn't learn any actual language. It was all just about like hardware and architecture and everything.
Right.
Yeah, but still, like one thing I noticed is there was a lot of emphasis at the time on like C++, and like they're very much a C++ school, which actually, as an aside, I realize makes sense now because sorry, I think his name is Richard Sutton.
Okay.
Uh,
Yeah.
yeah, he actually is a professor at the University of Alberta, so I think their computing science department is pretty strong. And because he's focused on like more or less robotics, it's like robotics uses a lot of C++, so it
Right.
makes sense that there's that influence there. But because of that, like I didn't know what programming language to use, but I remember like everyone there was using that, and so I figured that's what I'd learn. So not to go too much longer with this part of the
Yeah.
story, but yeah, but so yeah, so I was working at a hotel, and there were definitely the busy periods, but like when it's off season, you have slow periods, and a lot of times you're just sitting there not doing a lot. So I actually like as long as I got my work done, I made sure with my spare time sitting there, I just studying C++ because I'm
Nice.
sitting in front of a computer all day. Yeah.
Did
So
you, was there any book or anything? I'm just curious that you were studying at the time, or are you just reading the standard from the PDF? And
uh, no, I couldn't find the standard at the time. This is like
early 2000s, that would have been much harder. Yeah.
I don't think there. Actually, I'm not sure. It was a long time ago. I feel
That's
like
all
there
right.
wasn't. I feel like there wasn't a book. It was just like some tutorials and stuff, and it was a steep learning curve because like there's like C++ probably isn't a good language for beginners, like complete 100% beginners.
Right.
You know, yeah, and so like there's a whole bunch of things I had to learn just to get like Hello World working. And I was like, why is this so complicated at the time? Like it makes sense now, but
Yeah.
yeah. So, but I still had the opportunity to start exploring it back then. It was all just basic command line stuff. I actually wrote my own small program to help me with my job because you had to like, well, no, I mean you had to like write up like accounting related stuff like at the end of your shift. And so, I created a program where it could all just be printed out. I type it in the computer, and it could save time because it does the calculations for you.
Nice.
Yeah, but yeah. So that was my very early introduction exposure. And so the third story is okay. So I returned back to school, and actually, I was taking Japanese, and I was actually really struggling with it because there's a lot of characters
Yeah.
you have to memorize. And well, first like there's two scripts: the hiragana, katakana, and then finally the kanji, which is the more like Chinese style characters. But so to help me with that, I created a flashcards app. Um, because I knew a little bit of C++, I looked into like what kind of like visual C++ libraries or frameworks there were, and I decided to use Qt,
Hmm.
which at the time was Qt 4.83. It was just started with QML.
Okay.
Yeah, uh, so at the time it was still like very much like Windows based, and so it started on my laptop, and I I think I still have the code, but actually it really helped with my course. Yeah, I was able to actually successfully memorize, and get better at writing characters and everything, like reading and
Nice.
writing. Yeah.
I was just curious. You've mentioned now two things that were uh, typesetting of non-Latin characters, basically, right? And
Yeah.
and your journey. And so I'm just kind of curious. I imagine if I had my timeline of Qt correct, you probably had no difficulty with Japanese characters in Qt 4.8-ish, I'm guessing. That was probably had no problem laying those out with Unicode or UTF-16 or something. UTF-32 it uses, right, by default.
I haven't used it in a long time, but I think, as far as I recall, it uses all of them. No, it had good Unicode support back then. I had to
Yeah.
teach myself how Unicode even works in the first place, but uh, yeah. So
But you
yeah,
started with basically wanting you're talking about layout of like Inuit in uh, in LaTeX not working very well. Is that and this leads into the rest of your journey, I think, and computing. Is that fair to say? Like, is this a solved problem now? That's the question I basically want to ask at the moment. Is it a solved problem? Can you do the typesetting that you want, or is this still something or should we just keep going with your, you know, what you've been working on?
uh, no, that's actually definitely an excellent question. It Yeah, the desire for like this solved problem has been a huge part of my journey. But uh, for me, I would say the quick answer is no. But in all fairness, like I don't know the landscape of all the different programs and software out and libraries that are out there. And it's like it's solved in some situations, but in terms of the way I want to use it specifically, I'm going to say no.
Okay.
Yeah.
All right, then we'll definitely dig into that more. Is there anything else? Sorry, I interrupted your actual story about your journey into C++, if there was more that you wanted to say there.
Actually, there is one more story. So yeah, I was using this third or fourth part, is it now? It gets more into TMP and all the modern stuff I did. It's like how I ended up like getting into that area.
Oh, okay. Yeah, go for it. Yeah.
Yeah. So yeah, I made my flashcards app, and then this is around 2011, I think. Smartphones were just starting to come out, and I bought a very tiny smartphone. It was a Nokia when Nokia was still a thing, like when the actual company still existed. I know the name still exists now, but like it's some other company that like uses the name.
Oh, we
But
missed. Yeah, I mean Nokia. First conference I went to, I took my Nokia candy bar phone and I didn't even bother taking a charger with me because I knew I could call my wife every night for a week and the battery would still be good.
no,
Anyhow.
no, I agree. So mine was like it was very tiny, it,
Yeah.
yeah, like this big, but like its screen uh, never once cracked or broke over
Mhm.
the course of like 8 or 9 years that I had it, and like I used that thing for that long, and like it was no issues. The
Nice.
only Yeah, I'd still use it, but the only reason I can't anymore is just the battery just stopped charging. And I couldn't find any kind of replacement. So,
Oh, it's
but
terrible.
yeah, but point of bringing that up is uh, I was still exploring like the idea of the flashcards app, and then I was learning QML at the time, like as an extension of a regular Qt. But I figured out how to put it on my smartphone.
Oh,
Yeah, but and it worked and everything. But then at the time, I also had like a BlackBerry Playbook, which maybe not the best investment, but BlackBerry shortly after kind of
yeah.
came
Right
out.
at
But
the end of the life of BlackBerry, basically.
yeah, so I had that, and I actually was able to put my flashcards app on there, but
Nice.
still like learning to put it on these various devices. Like I did have to change my code a little bit from time to time, and then also playing with QML, I realized like for as much as I had like certain successes, I had certain limits with just C++ in my understanding, especially with like templates and like metaprogramming and generics. And so it's kind of one of my own like rules for myself that like if there's something I'm especially bad at or like I don't have the best strength at, I go towards my weaknesses to improve on those.
Okay.
Yeah, and so like I knew TMP was just you know, like it was just it's just a wall of misunderstanding for me. So I delved into that, and at that time I'd been exposed to structure and interpretation of computer program, the classic textbook
Right.
on Lisp. So I like after like maybe a year or two of getting used to TMP and like I wanted to create my own in the book they call it a meta circular evaluator.
Okay.
So basically it's just an interpreter for Lisp. But basically you use Lisp to create its own interpreter of itself.
Right.
Yeah, so but basically I use that basic design to uh, build or try to build the equivalent in C++ TMP or template metaprogramming, and it kind of worked partially. It was terrible. It finally broke when I got to recursion. I remember I had factorial, but it could only get up to like 10 factorial, and it took like 10 seconds. Uh,
That's
yeah,
fine.
yeah, but uh, well, no, I mean, it was a good experiment for fun. It helped me learn a lot, both in Lisp and in like more TMP stuff, like how I could push the boundaries of the compiler, that
Right.
sort of stuff.
So you are effectively evaluating S expressions in templates at compile time. Is that my understanding? Okay.
Correct, yeah.
Which is something I've also played with, but I didn't. Well, I've done. Anyhow, I get the appeal in wanting to do that.
No. So I guess to finish this part of the story and then overall journey, uh, yeah, at the time, because I did that, for one, I recognized I had my limitations because I couldn't quite get the uh, metacircular evaluator working completely. But then also, I came across a blog by Odin Holmes,
Mm-hmm.
and like he had all sorts of TMP stuff in there that like I'd never even seen, and
That's believable.
yeah, and like it totally blew my mind. So I realized, like I thought I was pretty good at that point, but I was like, I'm only okay. And so I studied his work and then explored that area for a while. Uh, but then after playing with variations on like what he did, I realized like you could take it further. And that's sort of what led in more and more into like more my modern project. It took a while, and like there's some variations along the way. I gave a talk at C++ Now in 2021.
Okay.
It was online at the time, so it's just pre-recorded. But uh, yeah, it was a practical TMP. I did a compile time register machine.
Hmm.
Uh, yeah, and so at that point, um, I'd realized like the limitations of the old style TMP, and like at that time everyone was doing like const expr. I realized like, well, I wasn't 100% sure, but like I saw a bunch of talks and like I saw a bunch of like notable people who were really pushing it and saying like, this is the way forward. And I was like, okay, they're probably right. So I took a chance on it, and like I realized like it's definitely the way to go compared to the old TMP style. So aside from having to learn to adjust to that, and like a few other, I don't want to say setbacks, but just I guess learning journeys along the way. That's what led to my like recent library and project.
Which is CCTMP.
Yes, short for continuation construction template metaprogramming.
Continue. Okay. And your do I have this right? The website describes it as a proof solver or something along those lines.
I'm using the word proof assistant because it's a popular
Persistent.
term.
Okay.
An alternative is theorem prover, but
Okay.
the way my tech work is or the way the tech or idea works, it is like those things, but it's also kind of not.
Okay.
Yeah.
So what does the uh, what does it do? What do you mean by a theorem prover or not? If you're not quite using the word right, I guess. Or what is the goal of this project?
Uh, like going back to my original goal from like the early 2000s of wanting to create like a variation of LaTeX. Well, not a variation, but like a alternative, I guess,
Mm-hmm.
and to solve the Unicode problem for in a way that's like more accessible to my people in terms of like storytelling and whatnot.
Mm-hmm.
Um, but yeah, like so those are my original inspirations, and like they've always been that hasn't changed. And so like this project, like the first step to creating my own programming language or alternative to LaTeX. Uh, ultimately, like I want to create a multimedia programming language,
Okay.
and so in order to do that, you have to create a compiler for your programming language as well. And so, like for me, C++ made sense, and so like I want to create a library that gives me all the tools to prototype and then eventually create like the very first compiler for this programming language.
Okay.
And so that's a big part of what this CCTMP project is. So uh, the way it works is like I'm taking everything I've learned from my journey, and so like I look at all these strengths and limitations of C++, and for me, one of the biggest limitations is um, uh, the type system. Well, like that's tricky. I mean, like
Well,
debatable.
any
I mean,
relationship with the tape system, yes.
yeah. Like in many ways, it's an absolutely brilliant type
Uh,
system, which is why I continue to use C++,
right.
and why I consider it my favorite language. I look at functional type systems, and especially modern ones. Like, I was creating that metacircular evaluator in Lisp, but it
Right.
was it's an untyped Lisp. And so if you look at more modern functional, they're effectively typed Lisps. So like, because I come from a math background, I understand the theoretical guarantees that such languages have, but I also recognize they're not as performant as like something you build in C or C++ that's designed more for the hardware.
Right.
Yeah. And so like, I like C++ for the performance aspect, but I think its grammar has become pretty complicated over the years in many instances. And then especially with the type system, like I mean, I understand they're updating it now to give give it all the features that it's had for the longest time, but with actual grammar designed for it, and thus, you know, improved performance at compile time. But still, I think like so. And it's tricky, but to an extent, I'm taking advantage of that, but also it's like in a way I'm trying to replace the type system with a functional one,
Okay.
which with modern C++ and all the tools it gives you, you kind of can do now.
And this is
Uh,
basically like an embedded DSL ultimately, or
that is part of it.
part
So,
of it.
okay, so well, I guess I gave a way too long-winded explanation, but for my project. But the way it works is at compile time, I have what I call our Concord classes, which uh, are just little mini type systems
Okay.
and functional type systems. And so the way they're coded is they're actually just flat arrays and everything's symbolic because it's all just numeric.
Okay.
Yeah, so it's like going back to maybe like 80s and 90s, you know, C compilers where you're just doing low level going back to the beginning in effect. But by building it that way, I can, for one, serialize it. So like
Okay.
if I build a type system and I build values with it or functions with it, uh, if you do all this at compile time, it'll if you build enough of it, it'll eventually slow down, take time.
Right.
But if it's a flat numeric array, like internally, you can just print it out to file or write it out to file and then read it back in the next compilation round. And that way you just like cut out all that extra work you did in creating that class or those
Okay.
classes. Yeah. So for one, that mitigates compile times, but then by having it functional type systems, uh, not only are they functional type systems, I'm taking advantage of some other modern math, which is proof assistance. I gave a
Got it.
talk about. Oh,
Oh, I was going to say, I don't know what a proof assistant is. So,
okay. Yeah. So I gave a talk about this last year at CPP North.
okay.
Yeah. uh, but basically, like in math, I remember back in the day, they solved like there's a graph theory problem. It was on coloring, but
Hmm.
like the proof itself was so complicated, they actually had to prove it with computer.
Okay.
And so it's like, how do you represent math proofs in the computer?
Right.
Yeah. And so um, the modern theory takes advantage of the Curry-Howard isomorphism or correspondence. Basically, in functional, you can reuse uh, a lot of the types you already have to represent your proofs or mathematical proofs.
Okay.
So like tuples, you know, that would be conjunctions, so like A and B and C. If you want to, rather than just like evaluating whether or not that's true, if you want a proof of that, then you need a proof of each individual one.
Right.
And so to represent that, you just hold each of those proofs um, in the tuple,
Okay.
and then that tuple itself becomes the proof of the conjunction.
Okay.
Yeah, and so it's I don't want to explain all of it here, but it's just one example. But
Okay. Does that imply then if I could just like make an if I can make an inference, I guess, um, then the kind of like if A or B or C is true, does that then become like a variant kind of situation or something like
yeah,
that? Okay.
exactly.
So there's the algebraic types that are used to in functional programming can be used directly applied to proofs.
Yes, and actually also the function type, that's an important one.
Okay.
So basically, if you have like a proof of the claim that A implies B, whatever A and B are,
Right.
um, if you have a proof of A, like it's if you want a proof of the entire implication, you don't want just like a single proof from A to prove like a single proof of B. You want every single proof from A to prove
Right.
some or to be mapped to. And so if you think of it like mapping proofs to proofs, then that's just a function.
Okay.
So you can represent implication as functions from proofs to proofs. And so, yeah, if you continue with this logic, you can get the entirety of logic itself, just like negation and or implication, and then also the like universals such as for all and exists.
Hmm.
Yeah, and so basically you can write down like within this style of functional programming, you can that becomes a proof assistant. You can create like specify any mathematical statement you'd like, and
Okay.
then you can come up with a proof of it.
And you've modeled all of this in basically compile time in C++.
The quick answer is yes. Well,
Okay.
so this is my very first type system at all, let alone functional type system. And because I'm doing it in a unique way that uses const expr,
Hmm.
I can't entirely rely on like traditional. like design implementations for functional type systems. Like, you can reference a textbook and see how they do it. And like, I mean, they don't give you all the answers. You have to fill in some of the details. But in this case, I can't entirely do that. I have to do a lot more of my own research because I'm doing something a little bit different because it's like context for C++. But so I have all the algebraic types working. I'm about to get the functional, functions working, as well as the universals. So they're called pi type and sigma type. So pi type is for all. Sigma type is exists.
Okay.
Yeah, but
Okay.
well, I will say though, although I don't have them yet because of everything else I have, like I've modeled in my head how they work, and they work pretty much the same way. So, like the fact that I have what I have so far is enough for me to know that the whole thing will work.
Right. So it's the answer is yes. It's in my head. Some part of it's in my head, but a lot of it is actually on paper now.
Yes, that's a much more succinct way of explaining
Okay.
it. Um,
So you have exposed, I guess, a question that I have had for a really long time, and I've kind of half toyed with it, but never got anywhere. And I've just kind of always wondered if I could directly express in templates something like prologue. So basically, if the template, when it at compile time, it would give me the set of things that meet the supposition or whatever that I gave the system. And it sounds like you've kind of done something like this, because prologue is like a theorem prover, right? I guess is this one way it could be
I'm not
phrased.
as familiar with Prolog, to be
Oh,
honest.
okay. That's fine. That's a homework assignment for someone else listening. Then they can see if they can take your take what you've done and apply it to prologue or something, perhaps.
Well,
Okay, go
one
ahead.
th- oh, so one thing I will say is like, so with C++, there's concepts.
Yeah. Mhm.
So like compared to that, obviously, well, um, so like I think there's a lot of overlap, but one of the differences with like if you have this style like proof assistant, like for one you'd have to write your own proofs, but at the same time, like I'm sure there's entire classes of proofs which can be automated. But part of the reason I created it in this general way is that you know like sometimes you might have a claim you want to make about like in templates about your class or whatever else, and like there might not be any immediate automatic way to like verify it, uh,
Mhm.
and so you can just manually come up with your own proof. And so yeah, I just wanted to like clarify like that is like a potential trade-off of this style.
Okay.
Like in the long run, you can have libraries which might automatically verify a claim you come up with, but sometimes you'll create one which you have to actually just do the work yourself.
Okay.
Yeah, but it gives you
So
that free.
if I might just take one step back here, you set out with the goal of making your own programming language that's multimedia geared. And step one was making your own uh, brand new type system embedded in C++ with a theorem prover in it.
Uh, yes.
Okay, just making sure I got that right.
Uh, to, to
It's
an
not the
extent,
traditional route people go in designing a new programming language.
no. For me, this gets more heavy into design. Partly it comes from my math background. I mean, math design and like software engineer design, definitely huge overlap, but I'm going to say not identical either. Uh,
Right.
yeah,
Yeah,
sometimes there's different emphasis.
for
But
sure. Yeah.
yeah, but with math design, like it's a lot more narrative design. Like you start with various branches of math, and then you, like as part of their methodology, you see how far you can go with as few assumptions as possible.
Okay.
Yeah, and like I think that's good for consistency, and then also like if I build my own programming language, like, I mean, I could have just back in the day gone out and used a bunch of different libraries from a bunch of different like sources and try to get it all to work. But like, if I run into a problem where there's a bug or whatnot, then I have to report it to people, and like it might take time to solve. And like, what if it's critical to my program in the long run? Like, I'm completely dependent on other people for that kind of stuff. So, uh, just as part of, yeah, like my own philosophy of design, I'd rather be more independent.
Okay.
Yeah. And so, you start with your own, like compiler with its own proof assistant, I guess.
So on the scale, the timeline or whatever of, um, I want to actually create, the programming language that you're aiming towards, the goal that you have. Where do you think you are? Like, do you have a proof of concept for the programming language that you're ultimately aiming for at the moment?
I have parts of it. So, like, even when I was like in my early 20s, starting to think about this stuff, I actually thought way ahead. And my target was actually to have it maybe, or to have my programming language maybe 2 years ago. So, like, I'm a little bit behind. Like, I gave myself a leeway of a few years because you never know what happens. But then also, with, uh, I guess, world events over the last 5-ish years, with the pandemic and everything else, I didn't account for all that. And so, uh,
Hard to account for that. Yeah.
yeah, so because of that, there's been I guess, a few setbacks in terms of timing, but then also some of this theory stuff is taking a bit longer than originally planned. But as far as I'm concerned, I'm not too far off target at the moment.
Well, that's good. I have a very personally, like, if I'm going to start a project and I think, oh, this project, I'll have it working in 6 years, for example, I'm not going to start, right? Um, the way I intentionally seek out projects that sound easy, but I have enough experience to know that they aren't easy, right? But it needs to sound easy in my head so that I'm willing to start the project, right? So anyhow, I commend you on the long-term goal there. And I guess while I'm ranting for just a second, I also want to do a quick shout out to the old school cross-platform, what we would now consider old school cross-platform development that you were talking about in your C++ journey, of like your Qt project that can run on Windows and on BlackBerry and on whatever random operating system your Nokia phone ran, right? Like,
Symbian.
Symbian, okay. And meanwhile, I'm lucky if a website works on both Chromium and Firefox right now. Okay, end rant on there, but we can get back to your language. I did watch one of your talks, the one from C++ Now on C++ as a meta compiler, and it's like I think there's a risk of you underselling what you are doing here. So I kind of want to give you a moment to like to really brag about it, I guess, if you're willing to. But it sounds like you've got, I'm going to give my high level understanding and you correct me where I'm wrong, and or brag and say that I'm right. Embedded script in your C++ code that you can parse and compile to your own abstract machine at compile time, at const expert time, and then you can either execute that function later or at compile time or at runtime, and then you can serialize the whole state of this thing if you choose to and reload it later.
For the most part, that's right.
Okay.
The one part that stood out was the abstract machine.
Okay.
So, uh, so the metacompiler aspect of it, like, this is kind of in effect, it's a hack of the C++ compiler. It's closer to old school TMP tricks.
Okay.
Not entirely, but well, it's theory based for one. So I always like to start on theory based. I find you run into less problems later on. But to give a really basic explanation of how it works is you start with continuation passing functions. Uh, Well, can I just explain quickly what that is, just in case
Yeah,
people?
go for it. Absolutely. Yeah. It's
Yeah,
always better to explain.
yeah. So continuation passing functions are pretty much just like regular functions, except they take one extra input. They take another function, and so the idea is you have a like if you evaluate one of these continuation passing functions, you do your regular evaluation of the regular function part, and then you take that output and you pass it to the continuation, like that other
Okay.
input. So in another way, this is like function composition, but just like
Right.
yeah. But so uh, like if you compose a bunch of these, uh, you know, you you can build like arbitrary functions, but like the insight back in the day that I had that actually started all of this for me, this modern project, is that uh, like with certain const expr tricks and a few TMP tricks, you can uh, create a controller in uh, just like a numerical array, pass that as a template parameter, which is then used to tell you what the next continuation is in the function.
Okay.
Yeah, and that way uh, you effectively can create, you create your own assembly.
Right. Okay. Yeah.
Yeah.
Go. Keep going.
Uh, yeah, well, so you hard code a certain number of these continuation machines that are generic enough that they can mostly be like mis, well, just like composed with each other. Like
Okay.
not every single one with each other, but like largely composable in such a way that you can create any program, like Turing complete wise.
Right.
Yeah, and so that's how you create your own like functions. So
So
basically,
you're
it's not
you're passing basically byte arrays as template data, right? As not as parameters to your template functions, but as template parameters to your function templates. Did I say
correct.
that right? Okay. I teach this stuff sometimes. Why in the world can't I come up with the right words for that? They're the things between the angle brackets. That's the data that you're passing, right?
Yeah.
Um, and those are byte arrays that are effectively your own byte code.
Yes,
Okay.
but the difference here is that uh, like there's no like virtual machine or state machine on its own because it's just telling the compiler to compose these functions, and so it ends up being like a regular function in C++.
Oh, okay. I missed that part. So at no point do you actually have to evaluate this bytecode. This does get, so at compile time, it becomes a bunch of C++ function calls.
Correct.
Got it. Okay, that makes sense to me now. I was kind of a little bit missing that step. Uh, okay. I don't know if that helps our listeners, but I can now better visualize what you're doing. All right. And so then that becomes something that the compiler itself can optimize because it has all that information at compile time.
Yes.
All right. Okay.
And uh, the one other thing I'd like to add is like this ties back into the functional type systems, like these Concord classes of mine, because like if you have like a byte array or numeric array, you can use that as the internal representation of functions in this type system. And because you can create these at compile time, they become compile time objects you can pass as template parameters,
Okay.
especially when you serialize and reload them. You just declare them const expr, when you reload them. And yeah, and that's so, yeah, you mitigate
Hmm.
compile times that way.
You can really benefit from the pound embed whenever that actually gets usable, couldn't you?
Yes. I'm looking forward to C++26. So my library is actually C++17 compatible,
Hmm.
but so I want to keep one version that way, but I think I'll make a 26 version because yeah, they have embed. They also have variadic indexing. I I do that myself, but it's kind of a like TMP hack. Uh,
Okay.
uh, but then also, what was the other one? Periodic indexing. I think I wrote a note.
Yeah.
Placement new.
Placement new at Constructor specifically.
Yeah,
Yeah. Yeah, that would be handy.
yeah. So those three will be very, very useful for this project.
Right.
Yeah. Yeah.
So you have an embedded DSL that at compile time with templates, you compile it into C++. But that's not right. Really the right way of saying that, because you don't have to call back out to the C++ compiler. The C++ compiler already knows what you're doing, and
Yes.
then it can optimize that. So, all right, as one does. Obvious. It's very impressive. I love the idea of what you're doing. And at the moment, you would describe yourself as self-employed but open to work. Is that accurate?
Yes. I'll be honest, I've never actually worked in industry before. I would like an industry job. Definitely, like that's how you grow, the experience, the people, plus, a job that ideally challenges me.
Mm-hmm.
In
Is
the
there
past, oh,
Oh, no, go ahead, please.
no, in the past, I've just worked a lot of like service jobs, food service jobs, or labor jobs, and you know, like they pay the bills, and sometimes you can have some fun, but like my, I guess, intellectual brain is never really challenged. So yeah.
Sure. That's my retirement goal. I want to get a job at a bookstore, something that challenges a different part of my brain, but that's apparently harder than I thought it would be. Anyhow, where do you want to work, and do you have any particular type of industry that you're looking at?
Oh, honestly, I'm pretty open. I think I would need to at least start working to get a better idea of exactly where, to see exactly what my interests are.
Right, but you are currently based in Canada. You're assuming, do you want to stay in Canada, or do you just open to whatever?
I'm open to a lot of places. Uh,
Okay.
yeah.
Well, just thought I'd ask. I mean, as long as people are listening to this episode, they might find your project interesting and, see if they want to hire you. And you are giving a talk at NDC Toronto, correct?
Correct.
And do you want to give us any sneak peeks about what new things you'll be sharing there, or whatever?
Actually, to be honest, this time around, like for those who have watched my previous talks, they're a lot more theory based.
Uh-huh.
Like there's still definitely C++, but yeah, I spent a lot more time on theory because like I'm trying to create a series of talks where I start with theory and show that like this project of mine is very much theory based. Like I'm not just ad hoc making stuff up. But so I gave a few talks that were heavy on theory. So I thought this one I'd spend a lot more time just on the C++ 17 tricks that I use to make this library work. And then I also thought, just to keep things relevant, I'd make comparisons with how you could solve some of the stuff with C++ 26 and possibly reflection, where it's applicable. Yeah. So
Awesome.
just, yeah, rather than being heavy on theory, I thought I'd just give some practical code for a change.
That's also useful. Yes, both definitely are useful. If I would personally love to see some examples of the type of multimedia that you ultimately want to hope to be able to encode in your end goal. If you have the opportunity to roll that into a future talk, that'll be my request.
Yeah, like, do you mind if I talk quickly about the multimedia programming language and
Yeah, go for it. Yeah.
well, like it. So this goal of a multimedia language is actually just another step along the way. The biggest project in the long run would be like a multimedia studio for Indigenous youth.
Okay.
So basically, in Canada, there's with a lot of Indigenous people in Canada, there's uh, somewhat of a mistrust of the education system, and that ties back to some of the darker history of Canada.
I've read some about that. Yeah.
Yeah, I won't go into this, not the relevant forum for it, but
That'll be a
So
rabbit hole for our listeners later.
yeah, yeah. But so like I grew, I was lucky. I was able to get. I finished high school. A lot of Indigenous youth don't even finish high school, so certainly there's a lot that don't even go to university at all.
Okay.
Uh, and so, I was lucky to be able to finish university. But for me, it's like, how can I, help my community or other Indigenous communities? And so, with education, I find that very important. And so it's like, how do you motivate youth to be more trustful of education, if not the schools? And
Okay.
so, um, for me, in my head, like I find a lot of people, they either want to tell their own story or help someone tell theirs, and that motivates a lot of people. And so, if I have a multimedia studio for youth, they can start out simple, and the idea is by then I'll have a bunch of software that's actually very easy to use. Just for starter beginners, and then for those who want to take it further, you know, uh, if I build the entire software base in house for this studio, then I can start showing them more like heavy tech or like other things if they want to get to like character design and like other sides or the business side like marketing, that sort of stuff, like for these stories. So it's just a way of getting youth to uh, be exposed to more education, other things they might like. Yeah, and so by having
Nice.
that tech background, I have that independence, but then also I can use it as a teaching tool if I put in the effort to build it well,
Hmm.
which is a big part of this complex journey of mine. Why I've created this complex project, and so uh, ideally that's it.
I hope that goes well. Thank you for sharing that. We're at the end of our hour. Is there anything else that you would like to share? Anything like if anyone's interested in working alongside you or interested in hiring you, how should they find you? Like that kind of thing.
Uh, so in terms of hiring, I'm on Blue Sky and LinkedIn. LinkedIn's
Okay.
probably more reliable for that sort of thing. In terms of working with me, um, the early stage of this project, it's my preference to work on it alone.
Okay.
I have a few reasons for that, but
That's fine.
uh,
Yeah, you don't. It's yeah. That's
no,
okay.
eventually, realistically, I won't be able to create everything on my own. Like I just
Right.
don't have the time, and so at some point, I will want to open up later parts of my project, and
Okay.
yeah.
But
Oh, and
LinkedIn, then, in other words, would be the best way to reach out to you right now.
yes, and then also unrelated to this, there's just one thing I'd like to add. I I'd like to say thanks to Rob Irving.
Uh huh.
Uh, yeah, the so a few years ago, he contacted me to be interviewed on CppCast, and at the time I wasn't ready. I wasn't comfortable with it yet. I hadn't really given any talks or anything public speaking, but so yeah, he was very kind and considerate about it, and so I just want to say thank you for thinking of me then, and I'm glad to be here now.
That's Thank you very much for saying that. I think honestly the community, I don't know what word I want to use in a way, I owes a debt to Rob in general because he got a lot of people on CVP cast, shared a lot of information. I never would have started a podcast. Rob did. I just happened to join along. And yeah, anyhow. All right, thank you.
Oh, thank you.